Hello my dear students, welcome back to your channel of learning mathematics. So today we'll be starting off with exercise 5.5, that is logarithmic differentiation. That is, here in this particular exercise we will be learning how to differentiate certain special class of functions by taking the help of logarithm. So in the last video I have given you a short video on some basics of logarithm. Since this particular topic has been reduced from the textbooks from all the classes, that's why I had introduced a small video, not the complete video, but the small video which concerns only the basics of logarithm. So I believe that you have gone through it. If not, of course I'll be providing it to you in the description box below, the link. You can just click on that and then check for yourself, and that will be of huge help, especially as I said in that particular video, in physics as well as in chemistry also. Alright then, so a summary of that, we will be needing this few concepts, that is product, quotient, exponent. So log of m into n is log m plus log n. As I have told in the previous video, it can be extended to 3 terms also: m by n log m minus log n, log x power n. The exponent can be brought forward, n into log of x. Log 1 is 0, log of x to the base x, or if the base and the term is same, then the value of log is 1, log x to the base x, when the base is also same, so the value will be 1. So all that has been discussed in the previous video. So here what we will be having in this particular exercise, that would be exercise 5.5. So in this exercise what we'll be having is, we'll be having some special functions, certain functions which may not be very easy to differentiate. So in those kind of questions, what we will do is, we will be taking the help of logarithm. Like in exercise 5.5, the first question that we have is, okay, I'll just start the solution straight away. That is, let y equal to cos x into cos 2x into cos of 3x. So of course this, it's not that since we are learning logarithmic differentiation, it's not that you will have to really use or take the help of logarithm. No, there will be certain questions where maybe without the help of taking log also it can be easily differentiated, so feel free to do that. This is just another tool that has been developed so that, you know, certain special functions which may not be very easy to differentiate straight up, we will be taking the help of logarithm. That's all. Okay, so it's not compulsory that no, you always have to use log. No, it's not like that. So here of course without the help of logarithm also we can differentiate, but if I just differentiate, then you might be thinking again, what man, you're teaching us logarithmic differentiation and then without log you're just showing us how to differentiate. So here in this particular exercise I'll stick to log. I'll stick to how to differentiate taking the help of logarithm. So now if you look at this question, what we will do now is, I will be taking logarithm on both sides. So once again I repeat, why do we take logarithm on both sides? So that the particular function can be easily differentiated, that's all. Okay, so we have log of y equal to log of cos x, cos 2x, cos 3x. So that would be log of y equal to, now here we'll be using this particular function, that is log m into n product rule, that is log m plus log n. So here we have of course 3 terms, so that will be log of cos x plus log of cos 2x plus log of cos 3x. So it's done. Now differentiate, we can start the differentiation. So differentiating both sides. So differentiating both sides with respect to x. This is the first question, so that's why I'm writing all these details and all. After other exams you can straight up just go for it. Differentiating both sides with respect to x. So since we are already in the fifth exercise of differentiation, let me skip the minute details. So let me just start differentiating. Log of y would be 1 by y. You remember implicit functions? Yes, do not forget. So dy by dx. Differentiation of log of cos x would be 1 by cos x. Okay, for this question, let me just write down chain rule again. Differentiation of cos x, 1 by cos 2x. Differentiation of cos 2x plus 1 by cos of 3x. Differentiation of cos 3x. So of course the problems are now, solution would be a bit lengthy. Okay, that's why we have to skip some of the minute details here. So differentiation of cos x is minus of sin x plus this one, 1 by cos 2x. This would be minus of sin 2x. Again, chain rule, differentiation of 2x. Do not forget the basics. Okay, that's where most of the students fail. That's not fail. That's what most of the students forget. The chain rule. So minus of sine 3x, and differentiation of again 3x would be 3. So then question is find dy by dx. Differentiate the following functions with respect to x. So I'll just bring up this y here. Sin x by cos x minus of tan x. Sin x by cos x, again 2x, of course, so that's only minus, twice is already there, twice of tan 2x, and here 3 tan of 3x. So that would basically be the solution. Of course, if you wish to arrange, then we can do that. So that would give us something like this. I'll just keep it here. So that will be, I can now use the value of y from the question. So the value of y was cos x, cos 2x, cos 3x. I'll take minus common, so that will be plus plus plus. All right, so I'm moving on to the next page. So that would be dy by dx equal to minus cos x, cos 2x, cos 3x. So since minus is taken common, as I mentioned, tan of x plus twice of tan 2x plus 3 times of tan 3x. I hope you've got the point there. You'll have your notes there. I hope you're writing down also, not just watching. So as I mentioned, you can see there y value from the question I have substituted, minus common, so it becomes plus. All right, so it's not difficult at all. It's simple, of course. Question number 2. Let y equal to, so you have to write this because in the question y is not given, just a function is given, so you will have some problems at the end. So that's why right from the beginning of differentiation, right from the first exercise, I had told you that develop the habit of representing the function properly. Now you see particularly this x minus 4. You see this kind of functions, again it's still possible to differentiate, no doubt about that, but try differentiating it, all the best. Okay, you might be spending the whole day getting the solution for this. So this is where this log comes into play, especially this kind of questions where log really helps out. All right, so okay, let me just rewrite this function once again. So this can be written as root over, so x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, whole power 1 by 2. All right, so now taking log on both sides. Should I write? Okay, one last time. Taking log on both sides, we have log y equal to x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, whole power 1 by 2. So I'll just continue here. So 1 by 2, if you remember this particular formula, log of x power n is n into log of x. This exponent degree can be brought forward. So 1 by 2 and we've brought forward, so this can be log of x minus 1, x minus 2, x minus 3, x minus 4, x minus 5. So again, I'll not differentiate yet, not yet ready. First see to it that it's ready for differentiation. After that only you start the differentiation. Now this is in the form of log of x by y, or m by n. So log of m by n. I'm going to show you the steps later on. We can just start reducing some of the steps. Log m by n is log m minus log n. So I'm going to use that. So 1 by 2 is a common term. So log m, we use a second bracket also, minus log n. Okay, so log y equal to 1 by 2. So this again product rule. So log of x minus 1 plus log of x minus 2 minus log of x minus 3. It should be plus, but plus into minus, since I'm removing the bracket, it will be minus. I hope that's fine. X minus 4 plus, but plus into minus again, it will be minus log of x minus 5. Got that? So I think it's now ready for differentiation. Shall we differentiate? So differentiating that one I'm not going to write. Okay, please spare me that. So differentiating both sides with respect to x. Chalo. So that's going to be 1 by y. Of course, solutions are going to be lengthy. Okay, upay nahi hai. dy by dx 1 by 2. Alright, what is log of x? It is 1 by x. And this one, see, as I said, the solution is already going to be lengthy, so we'll have to skip the minor details, but at least I'll show you for this. Otherwise you will be again thinking this guy hasn't shown us also this one also. So let me just show you that. So after that, if we just proceed with the chain rule, x minus 1. So what is differentiation of x? 1. Differentiation of 1 is 0. So 1 minus 0, that's going to be 1. So basically no new term will be introduced. So of course, for those who are very familiar with differentiation, you will understand that you can do that mentally also. That way a lot of time can be saved. So got my point, right? Or should I have to write? No, I'll not write. Plus here also 1 by x minus 2. Here also, if you just proceed with the chain rule, what will be differentiation of x minus 2? Differentiation of x minus 2 will be 1 minus 0. That's again 1. So again no new term will be introduced. So if you can do that mentally, that's really going to be good for you. 1 by x minus 3. Again differentiation of x minus 3, 1, 0. So again, so you see, that way you can save a lot of time. If you have all the time in the world during the exams, alright, you can do that, time pass. No? So dy by dx equal to 1 by 2 into y. I should have written that y right from here. X minus 1 by x minus 2 minus 1 by x minus 3. Sometimes of course you have nothing to write in the exam, so that time of course, yeah, you can write all the minute details and minute steps, because you have to sit for at least 3 hours. So 1 by 2, y value we can use from the function, that is root over of x minus 1, x minus 2, x minus 3, x minus 4, x minus 5 into this value again, which I'm not going to be writing, same value term. Alright. Okay, so it's as simple as that. Done. You can pause the video and you can note it down. I'll move on to the next question, number 3. Again, I'll name the function. Let y equal to log of x power cos x. So chalo, taking log on both sides. Log y equal to log of log x power cos x. So that will be cos x, can be brought forward. Cos x log of log x. So now, okay, differentiating both sides. with respect to x. So this will be 1 by y dy by dx. Alright, now we have to use a product rule here because we have two functions, trigonometric, logarithmic. So let's start. Cos x, chalo, alright. Actually, all these steps can be reduced, okay, if you are very well, if you're very comfortable with differentiation. You can do it directly also. I'm just showing you the steps. So let me not make that mistake this time. Why? I'll just start writing from beginning. Cos x, log of log x. So what is derivative of log x? Derivative of log x is 1 by x. 1 by x, but it is log x. So we'll have to proceed with chain rule. Even this step also can be reduced. As I said, it is my duty to show you all the steps, otherwise you will blame me later on. So that's why. So y value, of course, I can just use here log x whole power cos x. So cos x by log x, derivative of log x is 1 by x plus, okay, plus into minus minus, sin x log of log x. So alright, I can rearrange that once again, and that should be log x cos x by x into log x minus sin x. It is not difficult at all, okay, it is not complicated at all. This just requires simple basic knowledge of differentiation, and then you can just go on differentiating. You can see there is no complex differentiation being done here. Yes, just take the help of logarithm. That's it. Just take the help of logarithm. It will help you simplify your differentiation process. Of course, yes, it becomes a bit lengthy, but you can give it a, see, there is no particular differentiation formula for, see, we have the derivative formula for x power n, that's n into x power n minus 1. We also have the derivative formula for a power x, that also we have, that is a power x into log of a. But we do not have any differentiation formula for a variable power variable, x power x, we don't have it. Function power function, we don't have that formula. This question is of that kind. So here, how are you supposed to differentiate? There is no other way, but you still have to differentiate. That's why, that's when this log comes into play. That's when this log comes to help us out. And using this log, now this function which could not be differentiated, with the help of log, it becomes easy for us to differentiate. Yes, in that process, the solution might become a little bit lengthy, but at least our job is done, our solution, we have the solution to our problem. Alright, so yeah, that is it for today, just the first 3 problems. So you can just practice this once. And the next video we will try to solve more problems. So this was just introduction problems on how we are going to be using logarithm in this particular exercise. Alright, so fine then, I'll see you in the next video. Till then, take care, stay safe, and yes, practice well. Alright, bye bye.